Good afternoon everyone, TrackMan 44 here. And this is the part that we're going to start going back together with. I'm going to say part 7. Well, obviously we've already started, with the shackles and things of that nature, but we're physically going to begin the process of attaching a subframe to the gooseneck verticals. So we just recap for a second. Got everything up here perfectly level and plumbed, setting on the hoist. You can see the chain falls holding the cross member down here, right on the boss where the hydraulic cylinder attaches, and all the way back here I've got a 3x4 holding that perfectly level back there. And then to back those up, I've got these homemade tri-stands that you can incrementally raise and lower to put everything right on the bubble, and that's what we got right now. So we're getting ready to make the very first butt weld here. I'll explain all that to you as we go along. Now when you go start working with metal, anything other than sheet metal, where you got a lot of welding, heat does a tremendous amount of things to your material. Heat moves it a lot. You find yourself, if you don't have a jig, making the things that you're making, you'll find yourself having to tack pieces of metal on or pieces of pipe on or whatever to hold things in position, so it won't move whenever you're doing the final welds. But if you take a look right here, look at my side beam. This is a 2" by 6" 1/4" thick material, and you can see I'm perfectly flush right here at the very top. I'm perfectly flush right here. Oh, it might be a 64th or so, but if you look down at the bottom down here, there's definitely a measurable distance. I would measure that at roughly a 1/16, or maybe 3/32 of an inch. That this actually is warped outward. That's because of all the heat that I've exerted on this thing doing all those final welds. And then we're going to force this back in by means of what you call dogging and wedging. Okay. Essentially what you're going to do is take a scrap piece of metal, just any kind of a scrap, and cut you a notch in it. And we're going to weld that notch on here on one side, and then we'll take our wedges, put a wedge right here like this, a thin one, and then of course this will be welded in place. You take a thinner wedge and then you drive it in from the other side if you want. And then what you'll do, whenever you drive those two together, as they force themselves into each other, it's going to drive this backwards up against this right here. And once you have that in that position with the wedges in place, you can tack it fairly good into place and slide your wedges out, knock your dog off, and go ahead and finish your weld. But that's what we're going to have to do. We're going to have to dog and wedge this here to get that perfectly aligned. Now the other side is exactly the same, except for it's just the reverse. It's out just a little bit at the top. I think it is, if I remember right. And so we'll be dogging and wedging over there too to perfectly align the vertical upright with the subframe 2" by 6". So hang with me. We'll get set up and we'll get that tacked in across the top on that 2" beam. I just thought of something that's kind of important to make sure everything is reasonably in line. I've got this magnetic DeWalt laser level right here. It's a 3-directional laser. It doesn't come out the second side. It comes out one side, comes out top, and comes out the end. What you will do on this thing right here is you'll find you a place that you can actually square up and get a perfect center dimension on the trailer. Doesn't matter what you're building, as long as it's big and square. You want to get your center dimension and get you a square mark at dead center of the 2 halves of the trailer. And I'll take this right here and I'll set this right here to where we have this line, which is the dead center of this, directly in line with dead center on the vertical mark. And if you look in front, you can't see because of this, but my indicator laser coming out of the front of the level is actually shooting directly on another mark I've got on the center of this, so that I know that I've got this perfectly square. And then the laser that comes out of the top, if you see it in my hand right here, that laser is shooting straight up to my main beam up top. Now I went to the trouble of going up to that main beam and putting me an X dead center of the beam, so that I can target the center of this right into the center of that X, kind of like crosshairs on a scope, so that I can actually get this portion of it reasonably close to dead center of that beam. Then we went ahead and took the center of this, transferred the center mark to the front of this by measuring the front of the vertical risers in case there's any difference in dimension there. And then I attached the laser level to the front of this, and we used the front mark. You can see the front mark coming out right here. We use the front mark off of that line on the other side, straight up front, to hit on the center of the gooseneck hitch that's going to hook onto the ball in the middle of your bed. So that way we know we've got a reasonably close alignment between the center of that hitch, the center of the trailer, and everything is in alignment. Now let's go to the back end. What I did, I don't know that you can see right now, but there's my chalk mark, which is exactly half the width of the trailer. This happens to be 36 3/8 to the outside of the frame, dead center, to make sure that that's exact. We plumbed the mark with a square. We know this is perfectly level. We know that we've got a good square mark on it. And if you take a look, we've got this magnetic base on the back, and it's a very strong rare earth magnet. You've got grooves that you can align a mark. So what I'll do is I stick this on here, right here, dead center of the groove. You lay a square right across here and right straight up the side of the level to make sure the level is perfectly square, dead centered on our mark, which denotes the center line of the trailer, which will be the center line up there as well as on the front of the hitch. And then with this perfectly plumb, this vertical laser right here will shoot straight up on the beam, and it'll show you that you're reasonably close to dead center on the beam up there as well. Now, if we were a fabrication shop, obviously we wouldn't be doing it freehand like this. According to my brother, he's much older and wiser than what I am, and he obviously knows a lot more about this stuff than I do. I'm just dumb old air conditioner man, But at any rate, he says the guys that builds these trailers, in production, they have jigs and everything to where they cut their material all the same length. They build multiples at the same time, set the materials in the jig, weld everything in position. They don't have to worry about all this stuff like I'm doing here. But because this is a one-off time for me on this particular trailer, I'm not going to be building another one. This is what I've got to do it. But the main thing, you got to make sure everything is level, and everything is plumb, and everything is perfectly square. PLS, plumb, level, and square. And that's the hoops we have to jump through to make sure that that's the case on this, because we don't want to build a trailer that you're driving in the slow lane and the trailer's tracking down behind you halfway into the fast lane. You know what I mean? And let me tell you, there are trailers out there that are just about that bad. I hope I'm not building one though. Now what I've done all the way around this tubing is I went ahead and ground a little over half the thickness off to where I make a nice bevel, which will give me a much better shot at getting 100% penetration with this 70,000 pound tinsel. I don't know if you could hear that, but if you can make it sound like it's blowing all the way through the material, you know you're getting through the material. We'll clean the slag off of that before we make the next pass, but I'm very, very satisfied with the penetration I have on that. So now it's on about the business of dogging and wedging. It'll be welding one weld you don't have to worry about. It can be just ugly and nasty as can be, because you're just going to knock it off and grind it down smooth anyway when you get done with it. You just want to burn it in there to where it'll hold. I'll try the pair of thinner wedges first. If the thinner wedges don't do, then I go get the thicker ones. Okay, you can see my my dog welded on there in place, and I just hooked the one thinner wedge under here on the back side with the meaty part of it up against the part we needed to squish in. And then you can see, you saw me driving this in here, and because I made a crooked cut, the wedge kept wanting to slide down. I had to keep correcting it. But had I taken my time or had a perfectly 90-degree cut in there, the wedge would have driven in really, really straight. But it doesn't matter. This is not, this ain't rocket science. But I got that driven in, and if you can see now, this is perfectly flush right here with that part right there. So I'm going to go to the back side of the joint and put a little bit of a tack down there at the bottom to hold everything in position. Then we'll burn the rest of it in and then go to the other side. Okay, it's tacked in pretty good, about halfway up on the other side. So just take right here and tap your wedges out. and knock this guy off. And we'll grind that down nice and flush, and we'll be ready to do a vertical run right there. Now we got to use the wedge and the dog and pull this side out just a little bit. But now they got them wedges drawn in there. It pulled the bottom of this box tubing out flush with this guy right here. With every tap, you could just watch it come out farther and farther. And again, you weld on one side of the dog, the side that you really want to drive from. I should have driven from this side, or actually should have welded from the other side. But I figured as easy as this would move, it'd probably be okay after I'd already started. But at any rate, you could see it move out with every tap of the hammer. So now it's perfectly flush. I'm going to stick it on the inside and call it good. Okay, it's stuck pretty good on the inside, so we just tap it. There she goes. Grind that down flush, burn that in, and we're good to go. Now, I guess y'all can tell by the lack of sunshine in the backdrop that today's not the day that I actually finished up that portion of this project. That was back in October, so you know I am running a little bit behind. I thought it would be kind of interesting for you guys if you haven't experienced the way of straightening heavy metal, referred to as dogging and wedging. You know, we kind of get the slang talk, you know, say dogging and wedging, you know, but that's just the way, you know, that's just the way it is. But a lot of times you'll be putting stuff together, and heat on welds just moves the material just something fierce, and you got to come up with a way of forcing it back together. Of course, you have to tack it in place just like we showed on the video, and then you use those wedges and dogs, you know, to align something or force it back into place, and then go ahead and stick it for permanent. But anyway, that's just one of the little simple things that you do. But you know, there's tons of stuff. You've seen the come-alongs here and there, you know, stretched across the frame. You saw me welding like gas pipe across there to hold something temporary, you know, while the other portion of it is being welded. Well, those temporary braces get cut off and ground down. Well, this dogging and wedging just ain't no different. It's just another technique that you got to use to build something square, plumb, and level. What I say before, PLS, plumb, level, and square. But at any rate, I'm going to go ahead and get on about the business of doing something else. So you know what, this is Tractor Man 44, and I am out of here.